Multiple Spanning Tree Protocol, or MST. In this video, I'm going to talk about the next version of the spanning tree protocol. We call it MST, or Multiple Spanning Tree Protocol. First, we should learn about the reason that we are using the MST, okay, the necessity of the MST. After that, we can talk about the configuration and also detail of the MST. First, let me to review different versions of the STP that we have learned until now. You know that we have learned about the traditional STP. Let me to write here. When we are talking about the STP, okay, actually we are talking about the traditional version IEEE 802.1D. Okay, you know that in traditional STP, we are using the root bridge, okay, as the root of our net topology, and after that in each switch we are selecting the root ports, and also in each link we are choosing the designated port, and finally all other ports are alternate ports. And you have learned about the STP. But you know that in IEEE 802.1D, in one network, we have only one STP. Actually, in one bridge network, we have one STP instance. Actually, we are using CST or common STP. What does it mean? It means that, for example, in this network, the network include switch A, switch B, and switch C, okay, switch A, B, and C. We have only one STP instance. For example, assume that the switch A is our root bridge, okay, or root switch. And after that, because you have learned previously, you know that here we will have in each switch one root port. Okay, for example, in the switch B, okay, the root port is the port connected to the switch A. Assume that all of these links are 1 gigabit per second link. Okay, this is 1 gigabit and this is 1 gigabit, okay, per 1 gigabit Ethernet, and here also we have 1 gigabit Ethernet. Because of that, you know that this interface is the root port, and also this interface in the switch tree is the root port. All of the interfaces of the root bridge are designated ports. This is designated port, this is designated port. Between the switch B and C, the interface connected to the switch B is the designated port, and finally the interface of switch C has the alternate role or block state. All right, this is the common STP. Here actually we have only one STP instance. Okay, this is our STP instance, and this is the traditional STP. But you know that in this method of the STP, or spanning tree protocol creation, okay, spanning tree creation, if we have multiple VLANs, for all of these VLANs, the link of switch C is block. Okay, what does it mean? For example, here we have VLAN 1, VLAN 2, and VLAN 3, okay, in each switch. Let me to write here VLAN 1, VLAN 2, and VLAN 3 in the switch B, and also in the switch A, and also in the switch C. We have these three VLANs on the switch A, B, and C. You know that for all of these VLANs, the interface of switch C is disabled. What does it mean? It means that we don't use this, for example, link until one of the primary link fails. Okay, it is obvious. You know that Cisco created one method, we call it PVST or PVST plus. Okay, in this method, that is the abbreviation of the per VLAN spanning tree protocol, or per VLAN STP. Actually, we are using traditional STP, but for each VLAN, we are creating one specific instance of STP. For example, when you have three VLANs in each of these three switches, actually you have three STP instances. I have explained this concept previously, but let me to review it. We have STP1, STP2, and STP3. Each STP instance is working for one VLAN. For example, STP1 is the STP instance of VLAN 1, and STP2 is the STP instance of VLAN 2, and STP3 is the STP instance of VLAN 3. What does it mean? For example, in STP1, that is that are working with each other in switch A, switch B, and switch C, we can configure the switch A as root bridge. When you are configuring the switch A as the root bridge, it means that now we will have this topology. Look at here, this is the active topology for STP1. Let me to show you. Okay, here we have this active topology for STP1, and you know that STP1 is working for VLAN 1. It is so obvious, okay? But for STP2, we don't need to choose the same switch as the root bridge. Actually, in the STP2 or STP for VLAN 2, we are choosing the switch B as the root bridge. What does it mean? Our active topology is this topology. Look at here, STP2, and then here we have, this is for VLAN 2, so easy. And for STP3, STP for VLAN 3, we are choosing the root bridge in the switch C. Okay, this is the root bridge in the STP3, and this is our active topology. And here, as you can see, we have STP3, and this is for VLAN 3. As you can see, now we are creating 3 STP instances, and because of that, we can use 3 active topology. What is the benefit? The benefit is that here we don't, for example, shut down one link for all of VLANs. Actually, we are using some link for some VLANs and other links for other VLANs. Actually, here we can understand that the link between the switch A and switch B now is working for VLAN 1 and VLAN 2. Let me to write here. This link is working for VLAN 1. Actually, this is in forwarding for VLAN 1 and VLAN 2, and the link between the switch A and switch C is forwarding for VLAN 1 and VLAN 3. Okay, and as you know, the link between the switch B and switch C is forwarding for VLAN, for example, 2 and VLAN 3. Okay, this is the benefit of the per VLAN STP plus. All right. Also, you know that after STP, IEEE created the next version, okay, of the STP. We call it RSTP or Rapid STP, IEEE 802.1W, okay? And you know that RSTP or IEEE 802.1W again has only one STP instance. And you know that Cisco created Rapid PVST or Rapid PVST Plus. Okay, actually in Cisco switch we are using this method. You know that the benefit of the RSTP to STP is about the faster convergence time. Actually here about the fundamental roles, we don't have any difference. Again, in the Rapid PVST, we are selecting the root bridge, and after that root port in each switch, and after that designated port in each link, and finally we will have the active topology. But about the convergence, in the Rapid PVST, we have some new mechanism like the synchronization mechanism, and also proposal packet, agreement packet, and some other features that I have explained before. Actually, we know that Rapid PVST is like the PVST Plus is trying to use the links more efficiently. Now we have more speed. Actually, Rapid PVST is same as the PVST Plus, and the difference is related to the convergence speed only. That's it. Okay, but here we have one disadvantage. Let me to explain the disadvantage of the Rapid PVST and also PVST Plus. What is the disadvantage of the per VLAN methods? Okay, this is the first time we are talking about the disadvantage. You know that both of PVST Plus and Rapid PVST, okay, are trying to use the links more efficiently, and the difference between them related to the speed of convergence. Okay, but what is the disadvantage of the per VLAN method? Assume that here we are using this scenario, and we have, for example, multiple VLANs. You know that in each network maybe you have 10 VLANs, 100 VLANs, or maybe more. Okay, assume that here, for example, we have 100 VLANs. Because of that, we will have 100 STP instance, okay, in each switch. Actually, here we have VLAN 1, VLAN 2, VLAN 3, 2, VLAN 100. Okay, because of that, we should create automatically, this is automatically created, STP1, STP2, STP3 until the STP100. What does it mean? It means that now we have 100 STP instance. 100 STP instance means 100 series of BPDUs, 100 processing, 100 for example bandwidth usage of the link and memory usage. And you know that when we are increasing the number of VLANs, this resource usage is increasing.